4.1a, we're going to look at antiderivatives. Recall, if we have f of x equals 6x plus 3, then f prime of x equals 6, and the derivative of 3 is just 0. 3 is a constant. Okay, so I'm going to rewrite f of x as 6x plus c, where c is a constant. It's not a variable, it's a constant. Then f prime of x is still going to be just 6, because the derivative of c is 0. Okay, recall, if we have 3 squared equals 9, then we know the square root of 9 equals 3. So in this case, we squared, so we took a square, and in this case, we did the opposite. We took the square root. Okay, so in our case, if f prime of x equals 6, then to do the opposite, we use this little sign, and it's called the integral. Okay, so f prime of x equals 6, then the integral of 6 dx, and that's how we write it. When we do the integral, we want to get back. We want to get back to here. So the integral is going to be 6x plus c. All right, so here we took a square and then we square root. Here we took the derivative. And here we took the antiderivative. Okay? Here's the derivative. Here's the antiderivative. Okay, let's do another example. If we have f of x equals x squared, we know we take the derivative and we get 2x. Okay? So if we integrate 2x, and we write dx next to it, integrate 2x dx, then that's going to equal, we know that the derivative is 2x, therefore the integral is x squared, and then we add our constant. We always add our constant when our integral is open-ended. This is called the indefinite integral, and we'll get to that more later. Okay, so note something. I'm going to erase this and continue. Okay, note, y equals x squared. If we do this the long way, y prime equals, we bring the 2 down, and then we minus 1. And that equals 2x to the 1. Now I'm leaving it to the 1 on purpose to show you something about integration. Okay, so if we integrate 2x1 dx, notice here when we took the derivative, we subtract 1. So when we integrate, we're going to add 1. Okay, so we add 1 to our exponent. We keep our 2, and then what we do is we divide by what we have right here, plus c. So let's look at this. This just becomes 2 over 2x squared plus c, and that just becomes x squared plus c. Okay, so just to note, with the derivative we subtract 1, when we integrate we add 1. And to compensate for this 2, we're going to add 1 here, and whatever this is, we divide by it, and that will cancel out. So let's do another one. If y equals x cubed, y prime equals 3x 3 minus 1. So we took away 1, 3x squared. So now let's integrate 3x squared dx. We're integrating 3x squared dx. Okay, so what we do is we keep the 3. We're going to add 1 to the square, so that gives us 3 because we're adding 1. And then we divide by exactly what we put here, plus c. So our answer is x cubed plus c.